Good morning, everyone. So I'm Matt Farnell from EkkoSense. I head up sales and marketing. If you don't know us, we are power and cooling optimization specialists. We provide an AI-driven digital twin to help customers optimize data centers. I'm very happy to be joined today by one of our VIP clients, Ben, from Bulk Infrastructure. If you don't know Bulk, they are a leading provider, probably the leading provider of sustainable data center technology in the Nordics. So today we're going to be talking about some of the engineering complexities of AI deployments, high density, ultra high density, liquid deployments, Ben. Yep. But I know Bulk have very successfully deployed and at significant scale in infrastructure, so Ben's going to talk through that. So Ben, thanks for co-presenting today, good to see you. I know that you have a rich history in data center engineering and operations. Would you mind, I'm sure the folks here would love to learn a bit more about you personally. Can you give us your professional bio and then we'll come on to talk about Bulk?
Yeah, not a problem, and thanks for having me, and thanks everyone for joining this morning. So as you mentioned, my name is Ben Gliwa, and I'm the VP of Asset Management and Engineering for Bulk. Just to give a little bit of flavor, I guess my background, so 15 odd years in critical infrastructure, a little bit different to maybe some of the folks here is a mix of national critical infrastructure, water pipelines, high pressure gas pipelines, electricity and telecom across Australia and the UK. In operations and maintenance, and engineering and asset management. And then the last few years running operations and engineering for both Equinix in Sweden and Amazon. So still quite a big customer focus across both of those fields. And that's why I guess what we're talking about today is so important from my perspective at Bulk Infrastructure, and I'll go into our background a little bit. As things change in this industry and we hear about AI, but practically what does it mean from an operations perspective? And how do we need to improve? How do we need to respond quicker? And add visibility really and response prediction for us so we can meet those customer needs. So.
Absolutely.
Brilliant, so I guess what I'll kick off and just a little bit of context of who we are if you've heard of Bulk Infrastructure before. But as Matthew said, we're a sustainability focused Nordic data center owner and operator. So we have roughly 300 people across Norway and Denmark. We've got 3 main campuses across 2 in Norway and 1 in Denmark. And you'll see one of those in the background there. It's roughly 3.2, 3.5 kilometer square campus. So if you give that context, I mean, probably a lot of football fans in the UK, it's about 4,200 football fields, just for some context on size.
I have to say, Ben, having been there and seen the facility, even the picture is amazing, but it doesn't do it justice. It truly is an unbelievable site in terms of the scale that you're scaling
definitely.
over.
I mean, we didn't walk around all of it, you know,
Sure.
it would take a little bit of time, but I guess from our perspective, and we hear a lot in the industry about having power and land available, we're very well positioned for that. And the advantage of Norway and the Nordics in general is renewable power supply. So it's something like a 98% hydro backed in Norway. And we're situated right next to one of the largest substations and terminal stations in the Nordics and Northern Europe. We've got around 100 meg deployed. We've got a strong pipeline, 600-700 meg backed up, readily available. So we've really got the runway to kind of build for the AI demand and with our customers. But we also operate around colo sites as well. So we've got a main internet exchange in Oslo, and we have that spread of low density, high density deployments. So we've got standard colo, moving more into kind of higher deployments with some low as well. So you've got the complexities of air cooled, liquid cooled in the same data hall. But then we also have larger deployments, single tenant, 10, 15 megawatt, single tenant high density AI deployments. And that sort of brings...
Kristiansand is also well positioned, not just from a sustainable power perspective, Ben, but also connectivity, of course, as well to the rest of Europe and the US.
Yeah, exactly. I mean, I think that's a good point, Matthew. So we're a little bit different, I would say, to maybe some of the other providers, and you'll see here on the slides, we have some of those kind of front-end AI deployments, some very large AI deployments or high density, anything from rear door cooling, in-rack CDUs. So we're at the front end, and then we also have some of the traditional deployments. So we've got a very mixed spread, but obviously the pace moving forward with the AI and large-scale deployments is where we're at. The second, as you touched on, Matthew, we have a owned and operated fiber network, both land and subsea, roughly 10,000 kilometers of fiber interlinking Norway to the UK, across to Canada and the US as well, and then down to Denmark. So
it gives you almost global reach effectively for clients looking to deploy GPU systems or standard compute in your sites.
Exactly. And we're not just building sites as an island in the middle of nowhere in the top of the Nordics. They're interlinked, and so the millisecond speed is quite competitive for where our customers need to be.
Phenomenal stuff, yeah.
I guess what that brings is some challenges, right? It's not all happy days trying to roll these things out and build with our customers. And what we see is with that kind of growth, it's trying to meet that demand and try and work with our customers to have the right kind of designs on site, have the right operational framework to meet that response time. It's quicker build out time, it's quicker setup time, it's more interlinked from where the delineation between a customer and the operator is getting closer and closer, and we're getting liquid cooling right up to the chip, so it's getting a lot more blurred. And so that means our systems need to be a lot better to be able to work with our customers.
And your clients are pushing some serious rack densities now. We're talking about densification in the industry, which has been coming for a while, but we've actually seen it in your sites, right? You're deploying it today.
Yeah, definitely.
What sort of maximum per rack densities that you've got to now for your clients, would you say, Ben, if you're allowed to share?
So, I mean, we go up, like, we've got rear door cooling up to sort of 40, 50, and then we go up to sort of 80, 90, depending on the customer deployments.
Yeah, serious load, yeah.
So it's, and you've seen some of the other presentations, customers are asking for even higher, so we need to kind of pivot for that as well, and centralize CDUs and different kind of cooling systems to try and meet that. But build it fast as well.
Yep.
You know, you're looking at sub 12-month deployment timescales from customers now, so it's quite a quick pace.
Aggressive, yeah.
I mean, that helps. We've got the land and the power, so then we just need to build it and have the right design. So, and I guess, like in general, I would say our theme or the theme from our perspective today is that as we have those higher deployments at higher densities, the tolerances are getting tighter and tighter. So where you could have air cooling before, you could open up the doors if you had something wrong, you could deploy fans, you could deploy temporary cooling units. When you're getting high-end density deployments, your tolerance and your response time needs to be even faster. So the window is sort of getting smaller, and that's where we need some support and systems to be able to
I mean,
react.
fundamentally, running AI is much more complex, isn't it? We've got to manage liquids and air in the space, significantly higher rack densities. As you say, for every kilowatt of electrical energy we put into a server, we're going to generate a kilowatt of heat load. Can't get away from the laws of thermodynamics. And as I said, those heat loads, you have to be proactive rather than reactive. You can't just open the door anymore.
No, exactly. I mean, the analogy I always give is sort of a Cessna single prop plane where there's maybe 15, 16 different instruments telling you where you're going. You can deviate a little bit on flight, a couple of passengers. Hyperscaler, we moved to sort of the 747 jet. There's about 600 to 700 different indicators. Now we're moving more to sort of the F-35 there's less visual control panels, but it's all the systems and software overlaying, giving you that indication of where you need to go, because any deviation is going to set you off path quite quickly.
Yeah, so that's a good segue obviously into our partnership, Ben, and how EkkoSense is supporting Bulk with our digital twin technology to help you with that visibility and those systems that are running underneath.
Exactly, yeah. And we need those systems, and just practically having engineers and techs on site to be able to respond, it's not going to be fast enough anymore. Yep. We need that kind of overlay, and that's where we're working with EkkoSense on really trying to integrate our systems so we get that predictive modeling, we get a really good visibility of our site so we can jump ahead of it and support our customers.
Yeah, absolutely. So maybe just to share for the folks, if you haven't seen EkkoSense before, as I mentioned at the start, we create this digital twin technology, so it's a representation of the physical as-built environment. Highly graphical user interface, so very easy for engineers to interpret, but the key bit underneath is we've got machine learning and analytics running constantly. So this is a SaaS-based platform. I'll talk about some of the other benefits, hopefully, of the platform that we're delivering, but in this case, Ben, we're creating a digital model of the data halls that we can see here, but also the electrical system, and then we bring that to live with the context of live data integrated with your existing systems as well today.
Yeah, and I think it's important to note it's not just for super high density deployments. You know, particularly some of the challenges we face now is we could have a co-location space with 2 kilowatt racks next to 50, 60. And trying to manage the airflow, manage the cooling, and also optimize. You still want low PUEs, you still want to optimize your site for your power usage. To have these kind of systems overlaid gives you that ability, so you're not sort of shooting in the dark.
Yeah, plus the future capacity considerations in the space as well for more customer deployment as it comes in your pipeline.
Yeah, definitely. Optimization. It's all about trying to drive costs down, but keep the customers going.
Absolutely. So maybe if I can, I'll just jump in and just talk about EkkoSense a little bit here. So as I mentioned, we provide an AI-powered 3D visualization platform called EkkoSoft. And really our goal is to provide visibility. So highly visual platform, very easy to deploy, easy to use, but with the context of live data. We talk about quick to value. So in terms of deployment, we provide radio frequency wireless sensors, so we can deploy a 20 megawatt hall for Ben or similar operators in a week. So it's mega fast, can be up and running. Obviously the software runs on AWS, it's SaaS. Completely non-intrusive, so we can deploy into a live environment without any interruption to your business operations or your customers. It's an open platform as well, so we have open APIs, we have different methods of integration, so we can talk to existing BMS systems, as well as our friends at Bulk. We're working with other operators, as you say, we've pre-built connectors, so we can talk to Equinix, so we can get live data from the site into this platform to provide that single pane. And then we really do pride ourselves on something that's easy to use for operators. Obviously Bulk has a very comprehensive engineering team, but this system, any of us could use it and get value in seconds because it's highly visual. We can monitor and manage systems, so you can see we've got standard building blocks for things like rear door cooling, direct liquid chip, CDUs, etc., and we bring all that into the system as well. In terms of insight, we have continuous AI and machine learning analyzing data from the site. So literally the minute that you turn the system on, it will provide insight into power and cooling optimization, capacity insights, also your risk as well. And we get that through something called anomaly detection that we've had on our platform for a while now. So we're looking at patterns of data constantly, and we'll pick up any kind of misbehavior of a device before it gets to a critical incident. I'll tell you a little bit more about that in a couple of slides. And then another key dynamic on this is the automated reporting piece. We know engineering teams spend a ton of time on reporting, manual measurements, getting stuff into spreadsheets. We can automate all of that in our platform, and we provide some fairly comprehensive power reporting for yourselves, Ben, and also for your customers going forwards as well.
Yeah, I mean, if you try and reduce it down, it's sort of the engineer in the sky, if you want to call it that way, because at the moment there are a lot of manual processes still, even with some of the visibility that we have. But being able to kind of automate that and get that support on site just frees up the team and gives them the flexibility to really point them in the right direction and respond Absolutely. In a different manner. But our customer requirements are increasing. Visibility on the site, visibility of what's happening, what's going on, and that gives us that portal to kind of give them a view of that.
Yeah, absolutely. Yeah, I guess that's a good segue, and again, that's a question to you, I guess, Ben, in terms of an operational user of this technology in the context of all the complexity of the operations that your team is managing. Yeah. In terms of having an AI data center optimization tool, what does that bring to Bulk?
Well, I mean, I think it makes sense. We talk about AI in our scene a lot, and not as much using it within DCs, and I think this is the right pathway for us to go to really optimize, but just help our operations teams be able to set up for our customers in the best model. So, I mean, we're looking at capacity management in colo scenes, but also direct single tenants, optimization of cooling, power usage on sites, incident response I think is a critical one for us as well, to be able to kind of predict those issues ahead of time, hotspots, and deploy. So again, that tolerance, being able to respond to that kind of high density particularly, but also a mix of densities in those spaces, I think these systems really help us do that.
Yeah, for sure. And I guess this is foundationally part of the challenge that Bulk has for your customers in terms of effectively enabling the entire stack from a site and power infrastructure perspective, providing a safe and scalable environment, sustainable environment as well for data center hardware and these GPU clusters, and then obviously on that, your customers have got their client applications, and there's a lot of value in that. Yep. Running as well. It's a significant challenge, right, to manage all of this on a consistent basis.
Yeah, and I mean, I think we all know, like in different discussions that we're having, that the systems are changing every week, every month. The designs are changing. Different types, whether it's centralized CDUs or in-rack CDUs, the hybrid cooling methods, that continues to evolve, and it will. So we need these systems to overlay to be able to adapt to that as well, because our customer demands change on a week-to-week basis. Yeah. So we need to be able to pivot that to have those support systems so we can quickly adjust to their requirements. It's not set and forget anymore. It's sort of set, iterate, iterate, iterate. Yep. And how do we adopt from an ops perspective? How do we manage those sites? Yeah,
for sure. We're also cognizant of that at EkkoSense. We've brought a lot of innovation into our platform very deliberately to help with that dynamic. For example, at the site and power infrastructure layer, helping engineering teams like Bulk manage up to 10 power feeds per rack in a significant densification. Who knows where that's going to end up, Ben, in terms of the ultimate power density that we're talking about?
Exactly, and that's what I touched on. we need to try and shift and be adaptable because the customer need is just changing so quickly. So if we have these kind of systems in place that can move with us, so you don't have static infrastructure that, okay, we only measure this and this is how we go forward, we're going to be left behind with the customer.
Yeah,
base,
absolutely. And then another dynamic, I guess, is the value of the equipment that's running in these sites nowadays. We've gone from, as you say, traditional compute, thousands, possibly tens of thousands of pounds or euros a rack, up to potentially millions of rack, right? So in terms of that anomaly detection, early warning stuff, so your clients are a little bit more protected potentially from critical incidents before they occur.
No, 100%. I mean, the stakes have changed by orders of magnitude, right? I mean, in terms of rack costs a few years ago, and now we're at millions or multi-millions on a single rack. So when you look at your traditional ops response and the methods that you use to control sites, we need to upgrade and we need to innovate to be able to meet that kind of risk profile. Yeah. It's a different level if our customers are impacted now than it was, say, 10 years ago.
I can imagine. I can imagine customers are incredibly sensitive to that.
Yep.
So that it brings us on nicely, actually, in terms of those tighter tolerances that you talked about. AI workloads less tolerant of impact, so the need for that faster response time and intervention, and to get ahead of things as well. So as I mentioned in our platform, and this is one of the benefits of machine learning, using AI to analyze mechanical and electrical site data. We have cooling anomalies detection. So fundamentally, again, we're looking for misbehavior in patterns of data. So BMS is great, SCADA systems are great, but they're only going to tell you a problem when you've got a problem. So we look for things like, a really good example of that might be if the water system is starting to break down, and we run into things like sticky valves, which is a common problem right today. I've had other operators talking about that. You might get a valve that's starting to stick. It hasn't yet caused a critical issue, hasn't been picked up by the BMS, but you're heading into trouble if you don't proactively go and deal with something like that.
Yeah, and I mean, we've had cases where customers have changed their own equipment around, and we've had to fault find for them, and having systems like this helps us direct them to the right, even if it was non-ops, non-data center related, it's their own equipment, but it's so integrated now that we need to help them kind of fault find and
give
find
that over the shoulder look, yeah, absolutely.
So it really translates straight across to the customer side as well.
Yeah, so getting ahead of issues. And then you mentioned it as well, Ben, in terms of cooling, so we know we're in this hybrid cooling world, have been for a long time now. I know the NVIDIA guys were talking about the latest Vera Rubin stuff, so potentially bringing 45 degrees Celsius hot water to the chip. We know that direct liquid cooling will only take care of maybe 80% of the cooling load. We still need air in the space. We need air in the space to cool CPU compute. We need air in the space to cool networking as well. So it's a much more complex cooling environment to manage.
100%, and the different phases of life cycle for the customer, because they're not switching them on full bore on day one as well.
Right.
So you need ramp up time, you need to adjust your cooling setup to deal with that for the end state, but they may not get there for sort of 6-7 months from deployment. So you need a system that can adapt to those changing design requirements and roll-up stages. So.
Yeah, for sure. So with that, we are launching what we call our hybrid cooling advisor. EkkoSense, over our 13-year history, as a strong foundation in optimizing data centers, air-based data centers with our cooling advisor technology. So we've extended that now to be able to optimize chilled water systems as well, at the chiller level, at the CDU level, and obviously in the room itself. It's the world's first in-room optimization effectively. So what we're looking at is things like the IT load and the cooling demand as well, so that we're matching cooling demand with exactly what's needed. So we're not overcooling, we're not undercooling, we're hitting those sweet spots. We've also introduced failure modes as well, new failure modes that pick up things like micro leaks, flow restrictions, air ingress. So again, those kind of minimal things, Ben, that you might not necessarily pick up in a traditional BMS system that hopefully will give you much better granular visibility on.
Yeah, and I mean, it's probably similar to the, as cooling gets closer and closer to the chip, so does our visibility need to be. And we need to get closer, we need to get better data points, and we need to get more predictive data points, like we said, because that tolerance is so tight now and it continues to get driven down. If we don't move our systems closer to the chip as well, then we're not going to be able to react.
Yeah, absolutely. All right, so just to start to wrap up then, Ben, in terms of your insight, having that kind of global visibility you talked about, understanding what a good normal operation state looks like in the data center, just give us your kind of final thoughts on the whole piece, given what we talked about.
I think we talk a lot about the design side and the customer side and how the GPUs are changing. We need to translate that across to operations and our DC operations, because it's not a sort of single box within the data hall. It needs to all be integrated. We need to be able to support these systems, adapt our own operation setup and our visibility and our response. And that tends to lag a little bit. The new tech comes out, we roll it out into data halls, and then we go, oh, maybe we need to add this on top. And so for us, it's about leaning into that further so we can support our customers from day one and have those systems there.
Yeah, and having the visibility of digital systems to help your teams make those decisions and understand at a granular level what's going on.
Yeah, exactly, and support them, right? And not just sort of set and forget and go, good luck with these, 50, 60 kilowatt racks, and we'll come back and see how you go. But we need to have that integrated system. So we're sort of catching up, I think that the sector, and with solutions like this helps us really lean into that. As who knows what comes out next week with a new kind of design and requirement,
Having
right?
that crystal ball,
Yeah.
absolutely. So Ben, listen, thanks so much for sharing your insights today. Like I say, I've seen your facilities at Christensen there. It's truly epic in terms of a cutting edge engineering at an incredible scale that you're delivering. I'm sure you're going to win awards for it for many years to come. But thank you for coming and sharing your insights today. Appreciate everyone's time listening to the presentation. Hope you found it interesting. If you want to learn more about EkkoSense, come and have a chat with myself and Ben afterwards. Do come to our stand over at B20. Other than that, thanks for your time today. Hope you have a great day.
Thank you, everyone.
Thanks.